The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, a group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Thursday, April 27th, 2023. Our volcano is still swelling, but the story of this past week has been all the different earthquakes of all different kinds, all across the island, all over the place. So we've dealt with that, especially in the last day, but also going back for a lot of the last week, Dane. How have things been for you?
Pretty good. Actually was able to feel one of those earthquakes, which is kind of rare for me. So, it must have been really rocking and rolling then.
Yeah, that's right. Usually you don't get them down there. You don't get that wave or something about...
I'm sure they do. I just blame the dog normally when I feel something like that.
Right.
But yeah, it's been a, exciting week. Lots of, everybody feels the earthquake and then jump on the thing, see what it was. And it's been a lot of like, oh, is this it? Never mind. Maybe tomorrow, maybe the next one, and then do it again.
Yeah. So we'll talk about all those earthquakes for sure. There's been a cluster in Kilauea. There's been some under Mauna Loa. Nothing really changing there, but interesting to talk about. And Pāhala as well is still ongoing as well. So all the different earthquake types and kinds we'll cover here. Before we get into all of that, just a quick schedule note. Next week we're going to be switching things up a little bit. Next week marks the 5-year anniversary of the 2018 Lower East Rift Zone eruption. So to mark the occasion, we're going to be having a big roundtable discussion. on Wednesday, May 3rd, 5 p.m. my regular time. We will not be streaming next week, Thursday. Depending what's happening with the activity in the volcano, we may come back to you guys on Friday if we haven't been forced to cut in beforehand earlier in the week from something going on. That's our tentative plan. Anything you want to say about that roundtable forum, Dane, that we're hosting with?
Yeah, I'll say a little bit about it. I mean, it's going to be a bunch of community members and players from 2018. Some of them you would recognize if you were watching or living the 2018 eruption, and some of them are less known voices, but very influential behind the scenes. And so it should be a good discussion, I think. We're also going to try and get some people from county potentially to stop in and talk story a little bit as well.
Awesome. So yeah, look forward to that next week, and just a little schedule note for you guys to be aware of. Anything else, Dane, before we get into it here?
No, I think that's about it. If there's any questions, anything like that about Hawaiian volcanoes, go ahead and throw them in the chat, and we'll try and get to them in the end.
Okay, sounds good. Thanks, Dan. Yeah, Dane will be leading discussion, and yeah, we'll let us know if you have any issues with audio or video, although hopefully we've smoothed things out. We'll knock on wood here. All right. So let me get set up here and offer you guys here's this week's Hawaiian volcano summary. What you guys are seeing on screen here to start is the earthquake counts on Kilauea per week over the last year. So what you're seeing on the right side of the graph is the last week and a half or so, where the graph that caught most of last week exceeded 600 earthquakes per week, and where we are now is approaching 500 earthquakes this week. So really over the last week and a half, we've had about in excess of 1,100 events here on Kilauea. This is across all the levels of the volcano. We'll break it down a little more in our detailed update here, but the long and short is that the levels of earthquakes on Kilauea are now exceeding what we saw back in January of this year, the levels that preceded the January 2023 eruption of Kilauea summit. So things are really shaken there now. The volcano is certainly pressurizing and swelling and causing earthquakes all around it. You can see that back in the end of December and early January, it took 3 weeks of that elevated level to actually precede the eruption. For the eruption to begin, it began more or less in there. So we could have another week and a half of this coming, possibly, ballpark, a couple weeks, possibly a little more, possibly a little less. Just to note that the levels are reaching high there. This is a little different than last week when we were still down in here and looking at this thing climb. Clearly now you can see that the levels are at that threshold there. Not only do we see the high levels of earthquakes, here's a distribution. This is colored by depth, so really the population of interest is the summit area right over here, where you can see the distribution of earthquakes over the past week. Certainly pushing all around there for those intermediate depth earthquakes under the summit there. Following that same pattern, here's a tilt for the last month. And what you can see in the last week or so is a steady rise upwards here. Right? The overall pattern has been really since about 2 weeks ago or so coming upwards with these variations, deflation and inflation cycles superimposed upon it, but clearly a inflation pattern going on here. The ground is being bulged outwards from magma filling underground in the shallow part of Kilauea there. And even looking a little deeper at the GPS signal, here it is. It's the last year now, but the same pattern. It seems to be expanding. The 2 sides of the crater getting further apart, showing that the magma is swelling and building underground there. So Kilauea is at that breaking point. That means that at any point an eruption could resume. It could have a new eruption. You could have an intrusion. All of that could be said to be quote unquote imminent, right? That means within the next couple of weeks here or so. However, the earthquakes have not been only on Kilauea. Here's a map of the earthquakes for the last week on the island. There is a Kilauea cluster right in here. Our Pāhala cluster down in here has been flaring as well. But we also have a cluster underneath Mauna Loa summit that's fairly deep, as well as off of its northeast flank towards Kilauea there. What I'll do here just real quick is put up the list of earthquakes and just go from largest to smallest. To summarize our week here, we've had a 4.2 In Pāhala, that was last night at 4:30 p.m. local time. There it is right there. 30 kilometers down, 20 miles down, so one of the deep Pāhala earthquakes right there. The next largest in the last week was a 4.1 underneath Volcano Village over here. That was only 1 kilometer down, a half mile down. 4.1, very shallow. A lot of shaking, a lot of reports here. People in Volcano Village described how it reminded them of the 5-pointers we saw in 2018, 5 years ago, where everything was rattling and shaking around. So not the largest magnitude compared to what we saw in 2018, but the shallow depth of it combined with the location made it very impactful for community. Going down the list, the next one we see is a 3.9. That's over here on this upper left side of the map, on this northwest west flank of Mauna Loa. However, beneath it, because this was also down at great depth, 26 kilometers, so down a little less than 20 miles down there as well, showing the settling of the island and the flexure of the crust below it there. Those are the 3 largest ones this past week. However, I can scroll down here. There were earthquakes larger than magnitude 3, 6 other ones. There's a Pāhala one, another Pāhala one. We had a couple over here in this area. On the south flank of Kilauea, there's a 3.2 and a 3.1 that happened in the last couple of days. And then we have 3.0s up here on this flank of Mauna Loa, as well as northwest of Kilauea summit, there and there. So a little bit of the rundown of the earthquakes. That's the main story this past week. However, looking at Mauna Loa in particular, even though we have those earthquakes on its flank and beneath the summit, the levels are still quite low. So here we are. This is the last year of plots. Earthquakes per week, we're still down and maybe 40 to 50 per week or so here. Nowhere near the levels of building up, so it's still just a kind of a background process on Mauna Loa as it adjusts. And you could consider that Kilauea could be pushing and causing some of those clusters to flare up as well. So that's the Hawaiian Volcano summary this week. And with that, we'll switch over to our USGS update and dive into the earthquakes and some more detail here. So let's transition into our official earthquake segment, but put up our daily update from USGS first here today. Got something, Dane?
Nope, sorry.
Okay. All right, so here's the update from this morning, 6:30 a.m., Thursday the 27th. We are still at alert level advisory, aviation color code yellow. Kilauea is not erupting. No active lava observed since March 7th. Over the past day, no significant changes at the summit or along either of the volcano's rift zones. The magnitude 4.2 earthquake near Pāhala yesterday afternoon had no apparent impact on Kilauea. Otherwise, there's not a whole lot of information. They're noting the small changes in tilt. Earthquake activity in the summit region remains slightly elevated. SO2 emission rate, approximately 75 tons per day, measured yesterday, April 26. This is one of the lowest measurements we've seen in quite some time, 75 tons per day. It's close to the background. However, it still exceeds industrial levels. It's still causing fog of concern to nearby communities. But on the grand scheme of things, it's a pretty low value from what we've seen in recent times. Otherwise, nothing else new in the update here today, but just to note how they are noting the status of the volcano after all these earthquakes is still normal, and we're still waiting to see the ramp up that will lead to some new phase of eruption or breakout or what have you. I thought it would be a good time for us to review these 3 types of earthquakes in Hawaii. This is a slide that we took from Brian Shearer's presentation several years ago, where he outlines the 3 major kinds, right? The most obvious one of volcanic is up here in the top right. That's when you have some magma pushing through in a blade direction, and what you have is, as it's pushing through and wedging the rock apart, you're having small earthquakes occur along the perimeter of that area. You also get tremor from the moving gases or fluids moving through that crack as it progresses. So usually the way I like to summarize it is volcanic earthquakes tend to be smaller in size, but much more numerous and clustered together. So they often come in swarms, although that's something that also be confused when you have a big earthquake and aftershocks too. So got to be careful with that. Still, that's the volcanic kind of earthquakes. We also have what we call the flexural or mantle earthquakes. This is the kind that I've often called the settling earthquakes here. You have our big pile of volcanoes here on Hawaii Island, the largest of all the islands. It's pushing down on a lithosphere, that hard, still solid part of the lower crust and upper mantle here. And as it does so, that layer of rigid material is actually depressed beneath the volcanic pile, right? And so that means that you have a flexure of the actual lithosphere happening here, right? That means that in areas where it's bending in a certain direction, you see the stresses pushing away at the bottom and up at the top, and you get the opposite pattern off to the side here, right? So this goes to show what we talk about, what we mean when we're talking about these flexural mantle or settling earthquakes. So that's why they're so deep down, is that's the phase down here. And the last kind is this tectonic earthquakes, or edifice, as is shown here. And this is largely the ones that are the flank earthquakes, as we typically categorize them. You have the old ocean crust, which is within that solid part, and within that solid part you have this big red delineated fault line that's often called a décollement in geologic terms, but it's really, imagine it as a long, fairly flat fault. And that's where the magma that's filling in the magma chambers of Kilauea or Mauna Loa off to the side can then push sideways and cause this upper part of brown land to be moving relative to the crust below it. And that's when you can have these really big earthquakes that we've seen, like in 2018, that 6.9, back in 1868, the 7.8 or 8.0 or 7.2, all those ones all fall in this category. These are the most dangerous kind of earthquakes here in Hawaii, are these flank earthquakes. So those are our categories. We actually see all three different kinds here in this last week, which is why it's worth differentiating them and refreshing as I'm going to refer to these different terms as we go through here. So here is our earthquake map. We've already covered the largest earthquakes that we see here. Right? That's the pattern that we see for the past week. So I thought what I would do is look individually at some of these events. Here is our 4.1. That was the earliest one in the week. That was on Tuesday. So that's the one that was here underneath Volcano Village. There it is. There's our caldera area. Whoops, wrong button. There's our caldera area right around in there. Here's an earthquake just off to the east, near Volcano Village, nearly under Volcano Village, right there. And let's pull this back here. You can see there are quite a lot of fault reports, 88 reports. You can see the distribution of where those reports came from. Not as many, it wasn't as widespread island-wide, but a lot of them from my area here in Volcano. We'll move on from that for now. There was a USGS statement that came out shortly afterwards on Saturday afternoon. 4.2 kilometers south-southeast of Volcano, depth of 1 kilometer below sea level. Moderate shaking occurred during the earthquake and light damage has been reported. No impact on either Mauna Loa or Kilauea volcanoes. So everything else is that standard messaging there. Keep it moving here. The next one was a 4.2 yesterday afternoon, 4:30 p.m. Show you the map of that one. There it is down there, just offshore Pāhala, right in there. And this one, 261 responses, so felt more so island-wide. Here's a Did You Feel It map. You can see a better representation of reports submitted all across the island over here. For this one, I thought we could do some of these other tabs. There's all kinds of things hidden in here. This is that Did You Feel It report, but up here there's this series of tabs, right? So intensity of where the reports kind of came from. I like this zip code map. It shows you a little bit of where the responses were more intense. You can see how intense it was compared to the distance. That doesn't seem to be loading here. Responses versus time is not loading on this event either. So we'll try to get on a different one. Here is the statement from the USGS that followed yesterday afternoon's earthquake. 4.2 southeast of Pāhala at a depth of 18 miles below sea level. Widely felt. Intensity of shaking was very light, and little to no damage is expected. No apparent impact on the volcanoes. And everything else is standard messaging, the kind of summaries I've been putting out here. And then finally, the third one here, the 3.9, that was northeast of Honau. That's that northwest flank of Mauna Loa. There it is. Kind of partway between Hualālai and Mauna Loa here. And there it is right there. And for that reason, from its location, here, let's go back. And since we're going through this systematically, let's see what this Digifeelit report actually looks like here. Note 495 responses. So going to the Digifeelit, there is an intensity map. Let's try the zip map. So you can see in that lighter blue color was where you had more shaking reports. Intensity versus distance. So you see this is a logarithmic scale, but you can see that as it gets further and further away, the intensity drops off accordingly. Responses versus time. You can see how quickly people responded. Within the first hour, you're up to 451 responses there, and you end up at 478 there. So very quickly, reports coming in from all across the island here. So a little more in depth there on the earthquakes. Here's a USGS statement from last night. 3.9 earthquake at a depth of 16 miles below sea level, widely felt. Reported shaking intensity was light, and little to no damage is expected. And this one, the depth, location, and recorded seismic waves of the earthquake suggest a source due to bending of the oceanic plate from the weight of the Hawaiian Island chain, a common source of earthquakes in this area. The event is likely related to stress from the weight of the island on the underlying ocean crust, and was not directly related to volcanic processes. The earthquake had no apparent impact on Kilauea, Mauna Loa, or Hualālai volcanoes. Nice to see them include Hualālai in a notice there as well. 3.9, there's all the details reported. I'm not going to dwell on all that for you guys here, but rather move on to a different way to show this, right? Since we're looking at the depths, and the depths being a tell of the different kinds of earthquakes, I've now come to the main USGS website here and taken their map and colored it by depth, so it's a little more clear. So let me pull up the scale here for you guys. Let's put that up down here. So that maroon color is above sea level. Reds are within that upper 3 miles. Orange, the next 3 miles. Yellow, 3 miles below that. Then green, then light blue, then a purple, right? With really the blue capturing 12 miles of depth there, and then that purple being even everything below that. So when you look at this map right here, you can see all the purples are the deepest. That's likely the most deepest settling events. So you see that there's one there, there's one there, and one there. We do see some under Mauna Loa. We'll talk about that in a little bit here. Then you see the blue ones. That's the Pāhala zone, the deep feeder conduit of the hotspot up to the volcanoes, flaring at that depth over here. But otherwise, if you look across the rest of the island, you see all these other earthquakes. There's one there. All these events we've been seeing over the last week, and actually the last few weeks, all settling events, the green one as well, slightly shallower, but same pattern, all ringing around, all the ones surrounding the outside of the island here, all settling events from the weight of the island, and all the shifting that's occurring in the shallower regions as well. And really, you want to look at the red ones as being, just to note, that's that 3.9 right there, as one of those blues right there too. And all the red ones and orange ones are the ones actually from the magma near the surface. In the case of Kilauea over here, let's see if I can get this zoomed in a little more. There you have it. So that's that actual magmatic system here, and then the south flank off to the side getting pushed at the same depth by the magma. And likewise, it seems that there could be some effect from this bulging Kilauea to the north in Mauna Loa as well over there to that same similar shallower depth too. So just another way to look at this, colored by depth, maybe a little easier to absorb in this manner. Since it's all earthquakes this week, I thought I'd bring you guys a few different views of it. So let's play this as the actual island-wide loop. For this is now the last month and a half or so. So I'll let it play through. So zoom it in a bit. You can see Pāhala earthquakes have been gathering at a fairly steady rate down there, and these two separate clusters that seem to eventually join together here. That's been the pattern for the last few years. You see Kilauea summit filling in right there. A little more slowly at first, but flaring more so at the end here. We'll zoom in on it here just on our next slide. South flank has been fairly steady. You see it's still active right through there. The northeast Mauna Loa cluster kind of comes all at one go here in one burst earlier in the week, and actually is ongoing again today. And you see all the other earthquakes around the island are they just kind of pop up randomly. These background ones, the settling ones, are kind of all around the perimeter, all through there, right? All those guys. That's how it looks over the last month and a half or so here, zoomed out. To look at Kilauea a little more closely and examine this current burst that we're in the middle of here. One thing that these plots, this is, by the way, from the Iris interactive earthquake browser. So you guys can look it up on the internet, and you can manipulate all the parameters on the right over here. One thing that actually pops up for you is a little histogram. These, I believe, are earthquakes per day or per hour, something along those lines. So you do see how it was active at a lower level for much of that last month until really the last few weeks here, where it's spiked quite a bit higher, and spiked higher early on. Let's see if I can zoom this in even more. Right? Spiked higher early on, and it's been the peaks have been reducing, but you see this background level at the bottom has been stronger for the last couple of weeks, and that's where the bulk of your earthquake counts come from, is through there. So looking at the map itself here, there it is. See, it's been active for a while, but here this last couple of seconds before it loops, that's when it's really shooting up and building up the numbers. So background levels, and then here flares all over the place. Not quite to our climax yet, but you can see it's building there as the crescendos here. Just seems like it's just a matter of time now. How much time is the question, right? So those are that's the earthquake maps. We'll come into our charts on Kilauea monitoring, looking at earthquakes as well. So here are the last month of earthquakes per day shown, and that is 100 earthquakes per day right there. So you can see that for 4 of the last 5 days, we've actually exceeded 100 earthquakes per day. Last week we were saying, well, actually 3 of the last 4 days exceeded 80 earthquakes per day. So we've stepped it up from 80 per day as our normal for the past week, for 2 weeks ago, to the last week it's been about 100 earthquakes per day. Just to note, the bar on the very far right is not complete, so as the day completes, that'll rise up and probably come to match these other ones up here. And you can see that similar pattern that we saw in that tilt plot I flashed on early on during the summary, where it was fairly steady for that first couple weeks of the last month, and in the last couple of weeks it's really been ramping upwards there. So you can see that very roughly shown here. Looking at the earthquakes still over time, but against depth now, there you see that break more or less through there. Right? You can see that there's been more activity both in the shallower regions and also in the deep Pāhala zone. That's something that maybe is more obvious since we had that 4.2 yesterday. But that's how they plot out over the last month. Right? But otherwise fairly steadier in a deep zone than in a shallow zone, where that gap really is up here in the shallow for the most part. Still, if I zoom it in, you can see there is the big earthquakes. That big circle that's orange right there, that was that 4.1 under Volcano. Here was the 4.2 under Pāhala. And I want to say that, let's see, that 3.9 is probably that second one right to the side of it, right over here. Right? So you can see that overall the circles are getting bigger, and there's more of them all stacked on each other. So it certainly is interesting to note that it's been ramping up both at the shallower areas and also deeper areas, right? This is something that we still don't quite know the connection to Pāhala, but there are times when it seems like when a shallow area gets clogged and pressurized, you do see that flare up at the deep zones as well. It's not always one-to-one. You don't always have the shallow with the deep. Sometimes you have only deep, sometimes only shallow, but in this case we're seeing them both together, which is interesting to note here. Looking at the map, this is the last full month here. So you see that cluster of deep earthquakes there, but that more populated map of the summit. See quite a big cloud all through there. You do see it does trail off to the southwest a little bit there as well. It's interesting. This area to the northwest is one that we often have seen flare before when the magma is pushing in that direction. So maybe not the magma right there, but adjacent to the magma. Whereas more likely this area right through here is where I'd put my money on, where the magma has been putting most of its bulk. Right, but obviously the 4.1 volcano is a little further to the right, to the east here. So it's either pushing that shallow structure of the volcano off to the east over here, or it's able to put some fingers in that direction and swell a larger area than just what you see in the center here. We'll have to wait and see. You can see over the last month, the south flank is clearly active, and especially with these bigger events and this upper part of it right here, this part closest to the summit. Not as many flank events, south flank events in Kilauea. The further east you go, all the way to Kapapa, you see hardly any over there. So really, it's all constrained to the summit. No earthquakes in any of this area of the rift zone. That's all through here, right? If magma was going in there, you'd expect that to be flaring off as well, or there to be a big arm that leads off in this direction. We're not seeing that at all. So it does seem like it's still all restricted to the summit here. Looking at the last week, so we filtered some of those events out, but even still you see how much is going on there at the summit, and you see that the south flank is still adjusting with 2 of those 3-pointers in the last week shown here. So we just looked at the projection with depth against the longitude last week as well. Last week we're looking at the whole last month, where we could see that vertical pipeline coming up a little more easily right through there. And the story is still that it's all in the shallow regions where this is building up, right? So that's how we can tell, and how we can try to share that with you guys, what it might look like from the side here, and a quasi cross section, right? Where we saw last week more activity of earthquakes feeding up into the volcano, and now we're just seeing it trying to spread out in the shallow regions where it's already ready to come up, and it's not really quaking on a vertical pathway upwards anymore. Right? But the thought, just to recap last week, was that this deep Pāhala source over here somehow connects over here and then up. Is the possible pathway that's been theorized. So that's the longitude against depth. Similar to what we saw for the monthly events, here is the last week with depth. So more easily you can see the 4.2, the 3.9, and the 4.1 back over here. And just see how active it's been at all the different levels here. And so finally, the earthquake plot that I started off our summer with, I think this is one of the most telling ones here. Earthquakes per week now, right? Showing the relatively high level of what we see over the last week and a half compared to the threshold of what we saw prior to the eruption in January 2023. GPS across the summit of Kilauea, north to south, expanding once again. We seem to see it take a little bit of a slowdown or a little bit dip the week before last, but it's all back on track now. Everything is as expected. Everything is rising and moving away from the center. So we won't go into any more depth on that today, but there is a pattern on the summit, getting further apart, distance increasing as the sides bulge apart. And the opposite pattern visible here in the rift zone, right, where we actually saw the upper part of the Middle East rift zone by Pu'u, got this contraction, the line distance getting shorter, closer together, slowed down. It seemed like it got a little bit flatter. It seems like maybe it's escaped whatever caught it, and it's resuming its original trend a little bit here, a little bit here. So that's normal to have these little adjustments. It is showing the little complexity that there is in that part of the rift zone where the summit's trying to bulge outwards, and all the blocks are having to adjust to that changing pressure up there. So that's the GPS. Here is our tilt. I just wanted to point out, sometimes the tilt is not always matching up. So when you look at your graphs, it's always important to look at the time range. This one in particular, for the last week of tilt, it seems to have stopped updating 3 days ago. So what you see is, looks like a little tail off coming down. You really got to go to this last month plot, where we can confirm that it actually goes through today. And in that case, we can see that full, more recent last 3-day rise in the tilt there. Right? What you can see in this plot for the last week, more zoomed in, is these vertical spikes coming down. That's when the ground is getting rocked from the earthquakes coming through, and the tilt meter actually moves and moves back and then resumes its original path forward there. Sometimes you get a very small offset if the ground actually moves. It doesn't quite come back quite to where it was, but it stays a little bit offset from where it was. You might see this kind of step that you see there. So you see those two. This is the ones from earlier in the week, last weekend, Saturday. Whereas if you go into the last month plot, you can start to see the ones from yesterday over here, these smaller little bumps right over there. That's a tilt signal, and just to show in comparison the tilt and a 1 month earthquake side by side, there's our baseline tilt and coming upwards, and our baseline earthquakes and then coming upwards. So very similar pattern there, all consistent, nothing funny going on there. What we don't see is gas coming out of the volcano, really, right? So really, I think we've shifted here from our earthquakes into our monitoring, which is, well, to be honest, mostly the earthquakes this week. But let's throw monitoring up on the board here, and we need to talk about our GPS and our tilt, and then coming to our gas. Right? Not a lot of gas coming out of the volcano. Here's a whole last year of SO2. So we're down here at the bottom right, almost near zero. We can see we've peaked at 12,000 and 14,000 tons per day in the beginning of January as the eruption began there. We zoomed into the last month, right back here. Our scale is now from 200 tons per day to 60 tons per day. So there's our 75 from yesterday. We had 185 or so the week before, and the two measurements before that were around 110 or so. So overall, this is all within the same normal variability of the background level. This is all background values here. But as we've mentioned, that can still be enough to cause fog and impact to nearby areas. Not only is there no gas coming out, we have the lava depth restored on a graph here, measured by the laser rangefinder, and you can see it's basically just still flat. If magma was still coming in below that crust and bulging it upwards, you'd see something change here. So flat ground, nothing injecting into the shallows, nothing injecting into the lava lake, no gas coming out, but quaking just below that level where it seems like it might come up anytime in the next week and a half, 2 weeks or so here. And that is the monitoring signals we have. So we've mentioned the gas is fairly low, but still has impacts. Let's talk about the impacts. Impacts on Hawaiʻi Island are the gas has been a dominant impact here for the last few years, right? Ever since 2018, when it was more of a lava impact, and that was what we don't like to see. So really, since then, it's been in a national park, not affecting infrastructure, but putting out a lot of VOG. This is the VOG mapping and projection program here from University of Hawaii. We have such little volume coming out from Kilauea here that it's not making much of an impact on the nearby areas. However, it does flash up here around the volcano area. You do see it move up Mauna Loa's flank into the saddle a little bit, Mauna Loa summit, and then down towards Pāhala as well. So it seems most likely around Volcano Village area, national park at this point in time, but also the downwind areas towards the south may be getting some of that as well. Looking at a shot from Purple Air, Citizen Science Monitoring Network from a little while ago. Green most everywhere on the island. You do see a higher value right around the volcano itself, as expected, occasionally blowing through there. Here is our air quality alert from National Park. Everything's been in the green almost everywhere all day. If we look here, let's see, everything's still showing green, 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 and anything that was orange, I think there was some at the visitor center here, and it scrolled off the map. But this week I did find the graphs, so I'll show you guys. Here is a PM 2.5 at the National Park Visitor Center, and a little bit more resolution here. That 100 value is that National Ambient Air Quality Standard. So we're still in that safe zone of the standard, but you can see that there are times when it is coming up and going down. And earlier today as well came up and went down too. Right? What I think is interesting is if you look at the PM 2.5 could be from various sources, right? And we know it can be part of the VOG, but usually it's going to have the SO2 involved. So this page does also have SO2. Here's SO2 at that Visitor Center National Park. Here it is actually popping up a little bit of SO2, not huge amounts, that earlier spike as well. So it does seem that the wind is shifting. And when the wind is shifting, it's blowing the VOG towards these instruments and picking up the extra SO2 and the extra PM 2.5. Right, and along those lines, We do have other plots that are measuring ambient SO2 around the caldera as well, but they also rely on the wind direction, and there could be variations in that plot from actual emissions variations or from the weather and the wind direction changing as well. That's what makes those trickier, and why we like to use the plots that we showed where the USGS integrates everything and reports the actual SO2 value tons per day. So that's our gas hazard update here. We will turn to the visuals next on Kilauea. So starting off by loading up the live cam here. There's a live cam of Kilauea. And what you're seeing is a quiet surface. It's off-gassing. You see the fume coming out there. Some mixture of water vapor and primary volcanic gases like the sulfur still coming out from there. It's important to note that not only do you have the magma itself that's coming into the volcano, but there's a giant pool of it underneath this hardened crust. All this area is all underlain by magma as well. It has largely degassed and cooled. It's erupted already, but there probably is still some remnant gas that you can still be venting for quite a while out of there too. So that's what it looks like quite on the surface right now. For the last week, here is how it looks. Daytime views only from the KW camera, courtesy of the USGS HVO. See some different directions of the gas blowing, right? That's the variation, blowing to the left, blowing to the right. That's to the east, to the west, back and forth. That's why you've seen those variations in a VOG coming up over the last week here. But otherwise, quiet on the surface. Nothing else to really note there. We can load up the thermal camera here. Let's give this a refresh. Probably doesn't change anything, but you can see that it's just that one hotspot at that west vent pond area, and otherwise nothing else popping up anywhere. So it's still hot underneath there, only really escaping through that one zone. Elsewhere, that hardened crust does appear to be cooling off to ambient temperatures. Very, very surface there. So, because it has been fairly, I don't know, for Kilauea, that's kind of welcoming, right? Like there's not lava filling the whole crater floor everywhere. The USGS did take this chance to go fly into there and go into Halema'ama'o crater and conduct a couple of surveys, actually sampling rocks this go around. So here is a little bit of the USGS imagery from that mission. Here's a sunrise view from inside the crater. Looking at that crater floor with all the gas coming out, low angle sun coming across. And I thought I'd read a caption for this one. It's going to tell us what's happening here in the series. Early in the morning, on Friday, April 21st, 2 crews of geologists from HVO flew via helicopter into the crater at the summit of Kilauea to collect geologic samples. One crew visited the crater floor to collect cooled lava samples from the 2020 to 2023 summit eruptions. Another crew scaled part of the crater's northwest wall to sample ash beds and lava flows dating back many thousands of years in a volcano's past. Both crews witnessed a spectacular sunrise from inside of the crater, as captured in this panorama from the base of the northwest wall. Image, USGS image by Mike Zoller. Awesome shot there. And that kind of sets the scene for what we'll show you guys. Let's show you guys first the crew that's on a crater floor.
So
there's a geologist
on that one, huh?
What's that?
They repelled in on that upper section, to that down drop block.
No, I think they actually scaled, not repelled. They scaled. They climbed. They landed, and then they walked up the pile of rubble. I'll show you.
They walked up the pile of rubble. Okay, yeah.
Yeah, I think I pieced it together. I'll show you in the pictures here in a minute. But we're starting off with the field crew on the floor first, right? There's a geologist in flight suit, flight helmet, standing next to this big spatter rampart, right? It appears that they are next to that. Here, let's read the caption. A geologist from HVO selects a sampling site on the floor of the crater during the morning of April 21st. Geologist standing near the eastern rim of the lava lake that was active in the western portion of the crater during January to March 2023. The mound next to the geologist is a spatter rampart. They form when bits of molten lava travel through the air and accumulate on the ground surface, forming a mound-like feature. Yeah, the rest is just a warning that they have training and specialized gear. But one thing that's cool to note is we've noted so that there is the actual edge of that basin, right? We call it the western basin where the lava was flowing in, and as it circulates, it spatters back up onto the edge of the lake. So we've been seeing that happening for a while. It's cool to see a relative size of this thing. To see a person standing next to it, that's pretty cool to see. There's some other views. Let's advance to the next slide here, where there's our spatter rampart off on the left. You see there's the edge of the crater there where that other side comes in, and the rest of the crater floor around here as well. And then looking further at the caldera wall in the background there. So you can see that that's one of the areas they were trying to sample, is find bits of lava that got shot out from that lava lake there. That's the crater floor team, and now moving to the other team on the caldera wall. Here is that a zoomed out photo of geologists survey the exposed lavas and tephras on the wall of Kilauea caldera. So in here, let's read the caption first. 3 orange-clad geologists from HVO can be seen in this image, in orange near the center. Not easy to see, but they're right there. We'll get to that here in a minute. The geologists collected tephra samples from the Uikahuna Bluff along the northern wall of Kilauea summit caldera. Kilauea has a history of explosive eruptions. Evidence for these events is contained within the many layers exposed along this part of the volcano. So there is that zoomed out view. If we go to the full scale over here and load it up, and let's zoom it way in. Let's try to zoom in some more. You get a little bit of the hint of, looks like 3 figures here. 1, 2, 3 that are down at the bottom of this pile of rubble. So look at the size of these blocks of rubble. Some of these blocks are about person size, right? Some are a little bit smaller, but those are some big blocks on that wall behind them right there. Right, so there they are right there. And what could they be trying to, where could they be trying to actually get, right? So here is the wall of the crater. You see lots of these darker areas. That's your regular basalt flows, lava flows that are overtopped, that which kind of just flows from that old summit area. The wider areas are a little harder to identify exactly, right? That could be something like a crack that has some mineralization on it, but it could just be discolored basalt as well. A more massive basalt, weathered a little differently, something like that is possible as well. You see layers that are red. Those are ones that often have been exposed more to either the elements at the surface or some fluid movement where you have a chance to actually oxidize, and they're basically rusting the iron in the lava rock. But then you also have occasionally, let's see, these brown layers. And if you scan across here, there's not as many of them. You got to go further back in time, right? Because remember, time is youngest up here and oldest down here. But if you look right in here, in this zone, right there, there is one of these brown layers. Right? There's a brown layer right there. Just a little bit. You see it's buried in rubble on this side. It's buried in rubble on this side. This thing may not be exposed for that much longer without having to dig out some really, really big rocks, right? So this looks to me like the target. If you look at this layer, there it is. There's a little bit of, there's a white spot right there. There's a whitish layer above it with a red. And I'll advance now to the next photograph that was released. Geologists survey newly exposed lavas and tephra in a wall. And here it is. There is the geologist up there on the side. You can see they've climbed up all these boulders to get to this site. There is that layer of brown right there. There's that white spot right over there. And above it, the white layer with a red above and below it right there as well. So that's my best sleuthing investigation. I'm guessing that this photograph right here corresponds to this zone right in here. Right? So I'm going to zoom it out one more time. That's right there. And there's the geologists making their way along this little piece of land. And then they're going to have to scamper up this boulder zone somehow. Maybe they came across, who knows how they got up there. I would try something like that personally. But in any case, that's why it's so important to sample that, and why that was a priority now, right? If you look around, you don't see that layer exposed anywhere else, and that could be a key ash bed that may not be exposed anywhere else apart from the crater wall. So that's a cool thing to see them sample. Very hard to see this geologist right in here. I like this version Dane put out. This is on Hawaii Tracker. We're really zoomed in to really get an idea of the scale, the size of Kilauea caldera, right? It's really hard to imagine how massive this thing is. We see these images week after week. These rocks look pretty big, yeah, sure, but to compare them to be a person size, that's a little bit more useful to know, right? That the biggest rocks you see there are exceeding the size of a human. Helping to take it all in, the size and scale of it all. So that is the USGS photo batch for this week. Here is a caption for this last image that I showed you with the ash bed, where the geologist actually made it up there to scoop some of it out. Geologists documented newly exposed lava flows and tephra layers in the northwest wall of Kilauea caldera. These new exposures will help us better understand Kilauea's long-term eruptive history, which alternates between effusive periods producing lava flows and explosive periods producing tephra and ash. Photo by Kendra Lynn. So mahalo to the USGS for this nice insight into the sampling season that's ongoing now. Right? All kinds of different sampling work and upgrade work and deployment work happening this summer, field season for the USGS that will keep updating as time progresses here. So that's really all the visuals we have. Yeah?
I almost think rappelling would be easier than climbing that thing up to that. That's not an easy journey up that thing. That's what, 500, 600 feet, loose rubble, not the easiest conditions.
Yeah, definitely. I would just consider that there probably are regulations for rappelling in the federal government, right? And certifications and all that. So probably requires more training and supervision than actually landing a helicopter and trying to scamper up some boulders. So that's kind of my point one. And then point two is you gotta make sure you got something really good to attach that rope to the top, right? Because basalt is notoriously brittle when it's thinly layered like this, and you really don't want to be going down somewhere you can't get back up, right? So that's
yeah, it's interesting. At least they did it, and worked around the limitations to be able to get down there.
Yeah, it's interesting, right? We saw these walls exposed. We got photographs before much of this rubble was in place back in 2018. But then the actual layers were partway up the crater wall, and they actually were kind of floating. You actually would have had to rappel to get there. So it's almost like the Goldilocks moment, where enough rubble was falling down that you actually can use it as a ramp to get up there, but not too much where the whole thing is actually all the way buried. So that was very opportunistic, and I'd have to go back and look at other photographs to see if there are other layers that are all the way buried now that they can't get to, or what else might be the progression there. But really interesting to note this field work here. So that's Kilauea. That's Kilauea observations. We can switch to Mauna Loa. Mauna Loa is also a place that has had some earthquake activity this past week. However, at the surface, no changes shallow. Here is our tilt meter for the last month in Mauna Loa summit. Still rising steadily, no major change from before. There are earthquakes on Mauna Loa, but not so many around the summit. Here is earthquakes per day. So looking at just this plot, you might say, okay, look, looks like it actually jumped way up here in the last couple of days. This upper value here is 16 earthquakes in one day. So not like Kilauea, where we're looking at hundreds and hundreds and hundreds, right? We're looking at a much lower value, and that's why looking at the scale is always so important here, especially this left one. The bottom one, depending on what you click, doesn't change. This is always 1 month. But this height will change depending on the automatic scaling here. So it has come up a little bit, nothing dramatic, and that's why overall the prognosis for Mauna Loa does not change. Nothing to be concerned about there. No changes, no eruption, looking like it's coming anytime quite yet. You could say that the input rate from Pāhala zone is likely very healthy still. feeding Kilauea and Mauna Loa both, so you'd expect it was not going to be quiet for 40 years again, would be my prediction. More likely you see it 1, 2, 3 years, more like in that range, since it is being fed. But here are the overall earthquake rates to keep track of as we go through this. So for the last year, here is a relative comparison. That slight rise at 12 fits right there. And that's our pre-eruption back in November, and going back to October of last year, the height and levels of earthquakes per week. You can see we're really quite a lot higher, nothing really happening in Mauna Loa earthquake-wise to be alarming there. To zoom out even further, the last 5 years now, the whole build-up to that eruption, right? So here we have 2018 was a Kilauea eruption happening right through here. Mauna Loa is actually pretty quiet. And then from there, it begins a slow march upwards. It does flare up early in 2021, where it seems like there was a big intrusion, magma coming towards the surface. Didn't make an eruption, but gave us an alert that the volcano was being replenished at a shallow level. It took another 1.5 years of it building up to ramp up. And you can see at that point, you were at over 1,000 earthquakes per month for a lot of time right through there. Whereas now we're down around less than 200 earthquakes per month still at the far right. So really, this is setting all the context. We'll look at some of the details of Mauna Loa earthquakes, but this is just kind of academic and curiosity at this point. Nothing of this for Mauna Loa earthquakes is alarming. But the first thing to note, Mauna Loa summit is what we're capturing with these counts. You see all the small dots around, that's the background activity. But interesting, these are colored by depth, is these blue and purple events right over here. So those are the ones that are deep underneath Mauna Loa summit. Let's scroll down here. Here's our longitude versus depth, right? So it gives you an idea of not exactly a cross-section, but a projection, what that looks like. All the summit activity when it was quaking was all up in here. The pipeline comes up. Let's see if we got it lined up. Yeah, the pipeline comes up somewhere through there. And these zones way down here are somewhere near the volcanic roots of Mauna Loa. And it's not quite clear if it's exactly magma moving through those root structures into the volcano at shallower levels, whether it's actually settling. Usually your settling events are not so spread out. So the fact that you have a several like in an area, to me, would make me lean towards these being adjustments of magma coming into the base of Mauna Loa and eventually going to work its way upwards, right? But it's not exactly clear from just looking at this on its own. Looking at time now, the last month against depth, you can see that Mauna Loa's earthquakes, as time goes on, here is that flurry that occurs down in that root system area just in the last couple of days here, possibly showing that the supply to Mauna Loa is still active and healthy there. So that is the summit earthquakes at Mauna Loa. I thought we'd come back to this plot over here, right, and just show you guys there's a summit ones right through there. Here is our 3.9 flank event that was settling, and then here is the last cluster of Mauna Loa I want to talk about. It's this northeast cluster over here. This is colored by time, so it's hard to pick these apart from each other as easily, I believe. So I thought I would once again switch to the USGS map. Here it is. We can really see these blues showing the deeper events. There's a flank earthquake. There is a deep under Mauna Loa summit events right there, the purples and blues. And then here you can see these are much shallower events on the flank of Mauna Loa to the northeast there, right? The thing is that this is the area where we've seen a lot of adjustment, both when Mauna Loa was getting ready to erupt and also when Kilauea was recharging after the fact. Right, it seems like somehow as Mauna Loa and Kilauea interact, there's their axis right there, right, where the summits connect. That's the line that connects the summits right there. Not too far off, you have this zone that's seeming to adjust as well. This is just south of the 2022 eruption site. So not surprising that the ground there might be a little bit looser, might wiggle a little more to allow this to occur, as that's the area most dramatically moved, opening and then sagging after the fact when eruption ended there. And we don't have the GPS data from this area more recent than that, easily to get to, so we'll have to follow up on that part of it later. But it does seem consistent, at least, with this interaction of Kilauea and Mauna Loa, that as Kilauea is swelling in an area over here, it sets off earthquakes in this area, but Namakani Paio that we know right over here. The stress keeps transferring towards Mauna Loa, and you also might get another event over here. That's just the pattern that I see. Not confirmed by the USGS, but that seems the most likely thing, seeing as we don't see any events under Mauna Loa summit. Like, it's not like we see earthquakes here and then migrating to the side like we saw in 2022. We just see deep ones under the summit, and nothing, hardly anything shallow, and then the separate cluster off here to the side. Right, and so that's by depth, but to really look at these and a little bit more detail to see the list of events, it helps to have this page back open again. So you can see that among these, there is a 3.0, there is a 2.9, 2.7, 2.5, 2.2, 2.2, 2.0. So these are all decent sized events. They fall into two clusters, one that's back around the 23rd or so, and then one that's more so in the last day or two. So that's the last curiosity of Mauna Loa's earthquakes there, right? So to put it in perspective, that would be something like a flank event. Right? These deep ones could be the magmatic events, and the one off to the side here could be that flexural settling event, all among Mauna Loa. You can see similar patterns in Kilauea, right, where you see magma signals in deep Pāhala and shallow Kilauea over here. You see the flank events off to the side over here, and the settling events would be ones further offshore, more than likely off here as well. So all kinds of earthquakes this week. That's been a focus of the week, and probably tired of hearing about earthquakes. So we'll wrap it up here with Volcano Watch today. Volcano Watch is a celebration of the Volcano Observatory system from the USGS that began with HVO over 111 years ago. So they are noting here, there's a nice image of the old technology station on the rim of Halema'uma'u crater. Right? The lava lake was down inside of here, so this is not the caldera rim, this is the actual inner crater rim, where they came to make observations of the lava lake early on. This was Frank Perret in an early time. But just really quickly, the USGS has evolved from that kind of proof of concept at HVO. There's a lot of history of how USGS was managed through here that I'll just skip over for now. It led to Cascades Volcano Observatory, authorized in 1980, dedicated in 1982. Right, that followed St. Helens. Note, St. Helens erupted in 1980, and then they approve Cascades Volcano Observatory by 1982. They have an eruption in 1986, an Augustine volcano in Alaska. 2 years later, they found the Alaskan Volcano Observatory. 1988, collaboration, University of Alaska Fairbanks, State of Alaska, USGS there. And Yellowstone, fortunately, did not erupt before they had to make an observatory. They founded it in 2001, largely because of the threat and the prominence in the media there and the attention required. There's also quite a lot of deformation happening in Yellowstone. If you don't follow Yellowstone, deformation happens there all the time. So it's something that certainly deserves extra monitoring, and potentially, especially because of its potential impact. California Volcano Observatory actually began as a Long Valley Observatory in '82, but switched to being a California Volcano Observatory with a broader scope of California and Nevada in 2012. So now we have these 5 volcano observatories: HVO, CVO, AVO, YVO, and CalVO, right, that form the USGS Volcano Observatory Network. So that's why now we have a whole new management level in the USGS to manage all these observatories, right? Dr. Tina Neal is involved with that. And lots of collaboration that occurs between all observatories, right? With research and deployment, if there is an eruption, everyone coming to one location. So that's something that's noted here as well. They do note that they are still working at the national scale to develop the National Volcano Warning System, NVEWS. There's an extra E in there. I wonder if that's supposed to be early or not, right? But I don't know how early you can warn. And they're participating in a virtual tabletop exercise led by CVO to practice responding to simulated unrest at a volcano in Oregon. Right, so imagine like a Mount Hood situation, something like that. That's what's going on with USGS at the national level and how HVO fits into that broader context. And I'll leave it for you guys to read more details on hawaiitracker.com if you like. The rest of this Volcano Watch article here, celebrating HVO, as it should be celebrated. That's Volcano Watch this week. Only a couple of community corner items to share with you guys today. This week is still National Park Week. There is an event at Kahuku Visitor Center over on Mauna Loa Southwest Rift Zone there. Saturday, 9:30 a.m. Hiaka and Pele. There's a excursion, 90-minute, 2-mile hike, free to explore the different phenomena represented by the two sisters there. Then on Sunday, this coming Sunday, is Bark Ranger Day, where you can bring your dog to the park and walk up and down, get a certificate, and this is on Mauna Loa Road, past Pua'ulu, where I believe they closed down the road, and you can walk up and down with your dog through that area. So that's what's coming up this next week. There's another talk at Kahuku on Sunday, and another hike, Rome's Divisions of Kahuku. And then April ends, and we move into May. There's all kinds of events in May, but we will just talk about what's happening before next week, which is that on Tuesday, there is a concert, live music with Olaloa, a volcano band playing a free concert. It is a unique blend of Hawaiian rhythm and blues and classic hits, right? Performed live there in Kilauea Visitor Center. And everything else follows a week afterwards, so I'll stop it there for our community updates. And yeah, Dane, that is it from me. I'm going to switch this scene and see if the sound stays on here. I don't think it did, so I'll put us back to where we were. And we can say our thank yous from here.
All right, well, let's...
When you're ready.
I'm wondering if it works for me. Is it working for me?
Yeah, I think I won't use that other scene.
No, thanks for everybody for tuning in today. You know, we rely on viewers like you to get the information out there. We don't have advertising budgets, so we rely on word of mouth and the shares and likes and all that thing to help with the algorithm. And then, you know, I know everybody talks about it on YouTube, but those likes, shares, subscribes, all that does really help. We did have a couple supporters come through. Want to acknowledge them. We had Harlita come through with $10 and say thank you for the informative video. We had Scott Jits Ed come through with $10 and say Kilauea is testing our patience. Mahalo for your vigilance. And then Gary Bryan, longtime supporter, came through with $40, says thanks Phil and Dane for preparing this community, showing resources for greater understanding. Appreciate all the support there. And we also would like to thank the County of Hawaii through the 5i Grant Program, which has helped to provide the resources to continue these updates, as well as our written content and short videos on Hawaii Tracker and the various social media platforms that we operate on. And I don't see anybody saying that I'm muted yet, so that's good. All right. We did have a couple questions here, not many. Yvonne asks, when we're looking at that cutout of the Helena Poly, she asks, are those all normal faults on the south flank? Helena Poly fault line looks like a bit like when it was when I was exploring the area, but I could be wrong. And yes. She says she'll be coming back this weekend to check it out again.
The answer is yes. Well spotted, Yvonne. Yeah, you're right. Those are normal faults where the ground is basically getting stretched apart and one block is moving down and away from the other one. Yeah, for those who don't know what we're talking about there, that's what a normal fault is. And yes, absolutely. Let's see if I can find that graphic. Put it back on here. Oh, there it is. All right, so she's referring to these right here, right? This is an example of a normal fault right there. And where this land is moving away, it's going to stretching the land out, and one side is moving down relative to the other. I'm moving away there. So, yes.
All right. Then we had one question come through about if the earthquakes were related to volcanic activity. So let's just go down quickly the rundown of the past week. So the earthquake last Saturday under Volcano Village was connected. Is that correct?
Well, it was pretty shallow, so it may not have been the magma directly, right? But it might have been the magma pushing on a rock next to it, and yeah. So
that counts still. I mean, we count those. The one on yesterday around 4 p.m. in Pāhala at 29 kilometers was not related directly, and then the one last night around 7:30 near Hualālai, or Captain Cook area, also not related directly.
Yeah.
Just to give a quick summary of those three.
Right. I mean, you could
some are and some aren't related.
Yeah, I mean, we're talking about the volcano as being a shallow structure, right? So that's why we're excluding Pāhala, because Pāhala is probably magma moving through there and building that area as well, but it's a deep down in the root and not connected to any single volcano. And so it's kind of way deeper down.
And we also can't correlate it to surface activity. So it's like it does a thing, and then it's like, okay, that's cool and all, but we can't use that thing, right? Like the earthquake yesterday, it's like, all right, it happens, and we realize it's Pāhala, and it's like, all right, well, carry on. Like, nothing more can really be done on that one, at least for us right now, with our understanding of that area.
Yeah. As I've said, I think that all we can really say is that it seems to supply from the hotspot is still very healthy, likely to all the volcanoes that it's feeding there. And so we should expect more activity in the years to come.
Yep. All right. Well, I think that does it for me. We will be coming back next Wednesday with a special presentation, the 5-year anniversary of the 2018 Kilauea eruption in the Lower East Rift Zone. And unless something happens between now and then, we will see you at that point. If something does, maybe we go live this weekend, see what we can do. It's all going to be by ear type of thing if it does go off before then, which has a decent chance, right? But again, we're still looking at the summit region around Kilauea. It's safely in the national park, around the caldera itself, and everything else is kind of not on the table right now. There's other things that have to happen first before, I still get people asking about the Lower East Rift Zone. It's like, still dominoes have to fall first, right? We got to do, we got to see the signals. So, yeah. All right. Well, thank you, Phil.
Yeah, thanks, Dane. Yeah, just to reiterate, it's got a lot of work to do before it could actually get down there. It'll happen someday, but it doesn't seem like it's doing the work yet to get there. So that's why we're confident along with USGS as well, right? Mm-hmm. And just so it's clear, on Wednesday we're going to be talking about 2018 exclusively, right? So we probably will not be updating on what's happening on Kilauea between now and then, and that's why we may come back on Friday. Next week, to catch up on just the Kilauea part of it without going back to 2018 once again. So we'll issue messages to let you guys know the schedule, but that's our tentative schedule right now, is Wednesday and Friday next week.
No stream on our normal time.
And
we got going.
Not on Thursday.
Until next time, unless something happens, that is it for me.
Thanks, Dane. And thanks, everybody. Thanks for your support. Thanks for tuning in once again, listening to all that info about earthquakes. Hopefully you guys have learned something. And if not, you're even better prepared for what's coming next. Yeah, I hope. So that's our goal overall, is to help preparedness, have everyone on the same page. So something does happen, there is no panic, and we can all educate each other and move forward. Right? So just to make that clear, what our mission is once again. So until next week, from HawaiiTracker.com, he's Dane DuPont. I'm Philip Ong.